Hello! Welcome to Math Again. I wanted to start off by going through these two study guide questions. If you could pull out your study guide, pause right away if you need to go find your study guide. These were two questions from yesterday's lesson that are pretty important before we start today's lesson. First of all, in number 7, 9g plus 4g. We can combine like terms which are terms with the same variable. You can also think about it as 9-letter G's and 4 more letter G's. And since they all look the same, we can just add them all together, giving us 13 G's. 9 gorillas at one zoo, 4 gorillas at the other zoo, 13 gorillas all together. 8 is similar, but not the same, because 8 adds in constants and our friend negatives. If you are not putting parentheses around the negatives or boxing them up or circling them up or something, you are making a giant mistake. Very super extra important to do that. Now you can see there's my gorillas again. 8 gorillas at one zoo, 4 gorillas at the other zoo, 12 gorillas. Then I have 6 negatives and 6 more negatives. All of those negatives can go together for 12 negatives. However, I cannot put the negative 12 with the 12G. Those negative 12s are not gorillas. They cannot go in the pen with the other gorillas. These were very, very important from yesterday's lesson. Extra super very important. Keep your study guide in your study guide section. Switch to your notes. The directions on a lot of problems today say deductive reasoning. Pause if you need time to find your notes. Deductive reasoning is a very fancy way of saying, think about each math rule that you need to use. And here's some choices. That stuck like glue that I already mentioned. Distributive property. One number on the outside times both numbers on the inside. Commutative property and switching the order. Combining like terms. 4 apples plus 3 apples equals 7 apples. Join forces or battle. 7 positives might battle 5 negative guys. So many rules make up these giant problems of today. So many things to think about, which means maybe 2 or 3 minutes per problem. That's a lot of stuff to think about. So I just plan on going right down the notes page. On the left, see it says this deductive reasoning. I have to think very carefully about which rules that I plan on using. No negatives, that's a good thing. Then look for distributing every time. Oh, I see it. 3 times 3 is 9. 3 times, 1G, 3G. Okay, now I'm trying to make that a simpler problem. So many gorillas today. 4 gorillas, 3 gorillas, 7 gorillas. Here's my constant of 9. That doesn't have a gorilla, so it stays by itself. They do not mix. Stays by itself. On the right, warning, warning, warning. This subtraction is not a subtraction. It's trying to fool you. That subtraction is not a subtraction. It's trying to fool you. I'm going to use my negative and distribute. Negative 2 times 5, negative 10. Negative 2 times 1. Then, whatever I haven't used yet, like 3 and 4x, comes down. Combine like terms. You had 4 x-rays in your hand when you broke your arm, but you accidentally lost 2 x-rays, leaving you with 2 x-rays. In the middle, 3 minus 10. You had 3, you lost 10. Negative 7 is left. Pause to catch up if you need. Warning, warning, warning. That is not a subtraction. It is a negative trying to trick you. Circle it, box it, put parentheses around it. Something. You can't just leave it. Monkeys can go with other monkeys. Yaks can go with other yaks, but you shouldn't put a monkey and a yak in the same room at the zoo. Four monkeys and 1 monkey make 5 monkeys. This doesn't quite make sense, but 6 yaks, 7 yaks ran away. You're at a negative yak. I know that doesn't quite make sense. Just go with it. Warning, warning, warning. This is not a subtraction 4. Trying to trick you. That's a negative 4. Negative 4 times negative 8, positive 32. Negative 4 times 17. Ooh, I need a side problem for that. Negative 68. Bring down the 12 I haven't used yet. "32 vultures and no other vultures to add to it. Stays all by itself. What does happen though, a battle with 68 bad guys and 12 good guys. Unfortunately, the bad guys win by 56. On the left, how can I get rid of these parentheses? I know, I can distribute. 6 times 2x, 12x. 6 times 1y, 6y. Bring down the rest that I haven't used yet. Warning, warning, warning. That wasn't a subtraction, it was trying to trick you. 6 yaks can go in the same spot at the zoo as 2 yaks, giving me 8 yaks. Look what's left. Positive 12, negative 12, nothing. No x's. I don't even write that down. On the right, how can I get rid of these parentheses? I know. Distribute. 7 times 2, 14w. 2 times 1, 2w. 2 times 3, 6. 14 walrus can go in the same pond as 2 walrus. Now we have 16 walrus. What goes with minus 6? Nothing. Stays by itself at the end. On the left, how can I get rid of these parentheses? I know, distribute. 2 times 1n, 2n. 2 times 4, 8. Plus 3 comes down to the next line. What goes with 2n? Nothing. What's left? A battle between 8 negatives and 3 positives. Unfortunately, 5 bad guys win. On the right, how do I get rid of these parentheses? I know, distribute. 5 times 1c, 5c. 5 times 3, 15. Bring down the 8c. 8 cougars can go in the same pen as 5 cougars, leaving me with 13 cougars. Minus 15 can't go there. That's a constant by itself. Last 2. Whew, this is a long one. How do I get rid of those parentheses? I know, distribute. What? Why is that 3 at the end? No big deal. Move it to the front if you prefer. If you want to leave it at the end, that's okay too. 6t plus 12 plus negative 30t minus negative 8. Huh? Minus a negative? You can't not eat lunch today. You can eat lunch today. Minus negative 8, positive 8. So what can go together? Well, 12 regular numbers can go with 8 regular numbers. 20. This doesn't quite make sense, but you had 6 tigers and you lost 30 tigers. 24 tigers still lost. We don't put the 20 with the negative 24 because 20 doesn't have a T. Last one here, people. Get rid of the parentheses by distributing. Negative 60x, negative 21x minus x. Oh, wait, that's a 1. Oh, wait, that's a negative 1. All of them are negative, so they're going to join forces. 60 negatives and 21 negatives make 81 negatives. Plus 1 more negative. 82 negatives. Easily the hardest math you've ever encountered in your mathematical career, which means you have to try extra super hard today. Yes, today is your day. Make it happen.